Okay. Good afternoon, all. Welcome to the PALS Industry Asted online lecture series on generative AI masterclass from LLMs to agents and knowledge grounded system. I'm Kishore from PALS Program Management Office. I'll be monitoring this session today. I would like to reiterate the basic instructions once again. For easy identification, please rename your Zoom display name as college short name hyphen your name. Participants will be stay muted and allowed to unmute only during the Q&A session. Chat box usage will be restricted. You can message the host or co-host. We will enable it only on need basis. During the session, if you have any questions to be asked to the speaker, please write to Ask PALS PMO. This mail will be monitored throughout the session. Ensure to write your name and college short name along with the question. Attendance link will be pasted in the chat box. Use registered mail ID to mark the attendance. Participants are requested to register in the Slido quiz at the beginning of the session. Feedback link will be shared at the end of the session. Now I request Mr. Ravi Jona, PALS champion, to give the opening remarks and introduce the speaker.
Okay, thank you, Kishore. Am I audible?
Yes.
Yeah. Suranjana is a research scientist in IBM India Research Lab. She has been working in the domain of AI, ML, NLP since last 15 years. Is responsible for infusing cutting-edge AI concepts into AI solutions. She has authored 20 plus research conferences and intellectual patents. Vaishik is a research engineer at IBM Research Lab India, specializing in natural language processing, NLP, and reinforcement learning. His current research focuses on developing intelligent agents for the infra-cloud domain and also on agentic understanding and analysis. Thank you. Now we can start the program.
Yes. Thank you for such a nice introduction. I am Suranjana, and with me today I have my colleague Vaishik. So together we will be talking about agentic AI, what it is and why it matters, and how it is basically shaping the future of AI. So we will in this tutorial we will be giving some conceptual and practical uh, knowledge about the agentic AI, so that it becomes easier for the participants to understand how agentic AI is different from the traditional AI and why they are so powerful, why people are mostly looking more towards the agentic AI in the coming future. Okay. So, so for the last couple of years or so, like, like we have been all working, we all know the power of ChatGPT and different LLM models. So traditionally, LLM model, like we all know the power of LLM, and then we do some give some prompts, and I think prompt engineering has been, and basics of LLM has been already covered earlier this week. So we all know why LLM is so powerful. Most of the NLP tasks and vision tasks, they are they are handled with great precision nowadays with LLM. But then also we need the agents now. So why it is that uh, now, like, as we have solved the simpler problems, something like question answering with an LLM, we want to move towards a holistic framework. Um, is there a question? I see some hands raised.
No, madam, probably you can continue.
Okay. Okay. So, yeah, as I was saying, now that we have solved the, I would say simpler problems like Q&A generation or summarization, then we are moving towards an era where we want to do a lot more with LLMs. That is, perhaps build a whole travel agent automatic. Sorry, my voice is not very well today, so please excuse me. Yeah, so perhaps we want to build more automated systems, like building a whole travel agent using LLMs, right? Or perhaps writing a whole book, contains books, everything using LLM. So how do we do that? So if I use LLM one time, then perhaps it is not that much of effective. And so here comes the agent. So agent is nothing but series of LLM calls using some more sophisticated techniques. So one thing is, of course, like, like we are allowing the LLM to plan accordingly. Like, let's say if I go to a travel agent and ask for a holiday plan, so there are a lot of steps involved. For example, planning the entire thing, understanding my request, my constraints, and then giving me a personalized plan, and then doing actions, for example, ticket booking, hotel booking, making sure that everything is coordinated, and any other booking if I am needing, then understanding that particular gaps and doing the end-to-end process, right? So a lot of planning and actions are required for an entire travel planning, right? So this is a quite complex problem where multiple things are needed to be done. And there comes the power of agents, right? So agent is, I would say the power of agent will come into the picture when there is basically a lot of things that needs to be planned and reviewed altogether. Now, if I just want to do it via a single LLM call, or a series of LLM calls without using an agentic framework, then perhaps it is little difficult, because like agents uh, give us the power to do all of these things together. For example, planning and doing some actions in a very nice way. The flow is very defined, yet the LLM has the power to do things on its own. So I can define something and I can instruct the LLM to instruct the agent to follow some steps. But the agent, if there is some a problem with the instruction, the agent might ask me back, like, this particular thing is perhaps missing. Do you want me to do that? So it becomes like your personal assistant. It's not only a task which you are asking the LLM or AI to do, but it can also interact with you, find out if any gaps are there, and suggest you something more than that, right? So the complex tasks, like, as I was saying, the travel planning, the entire thing, there requires a lot of things like reasoning, iteration, and validation. Validation perhaps from the user, perhaps from the other sources, if there are some other oracle or any other thing. So all these things are there in the agent scope. So it is much more than just a LLM call or a series of LLM calls, right? Or doing things manually by an LLM. It is much beyond that. So that is that is basically where the power of agents come into picture. So agentic AI introduces this shift, right? Instead of a static model, we have dynamic agents. These agents can plan, act, and adapt. They are not just responding, they're reasoning, making decisions, calling tools, and refining their outputs. And not only that, right, they are also ensuring that the results that we get are safer and they are more reliable. They are more, you have the explanation. That, the agents are doing this particular step because of this kind of planning. So a lot of reliability on the agents are there instead of just doing a single LLM call. So for complex solutioning of any tasks, right? So I think agentic AI is the way to go. It's not just LLM call, but it gives you a whole package by which you can solve many complicated problems. So let's look into this whole idea, like, what is the difference between an agent and an LLM, right? So LLM, like GPT or Llama, is a foundation model. It generates text, predictions, or completion, but by itself, it does not have a memory or planning or access to real-time tools, right? So it is good for doing, atomic tasks. Atomic task means just perhaps you ask it to, to plan something, perhaps it will do, but to do the entire process of a particular task end to end, this is difficult for an LLM. But agent, on the other hand, is a system built around the LLM. It augments the LLM with planning, ability, tool usage, and memory. It will also ensure what input needs to go into the LLM to get the best possible result for completion of the particular task. So think LLM as the brain and agent as the whole person. So the person is actually telling to the brain like what exactly to do. The brain generates ideas, but the person can actually understand and say like, remember the past experiences and give more information so that the LLM can do the job in the most efficient way. So agents are what make LLMs practical for complex real world workflows. Uh, and then, of course, there is a big shift towards agentic because the security is much more. Consider this whole idea that, there is, you have deployed a particular system in some private cloud somewhere, and some other person, you need to make it accessible to some other person. So all these particular security aspects, it is very easy and doable in agentic AI rather than just using a simple LLM. There is always a problem of security, how reliable the system is, security and explanation in an LLM, which is being currently handled in agentic AI in a much more smarter way. Okay. So there are different frameworks which talk about which enables us to build some agents. The most popular one being LangChain, LangGraph, Creo AI, AutoGen from Microsoft, and IBM also has its own orchestrator which enables us to build agents, and the A2A framework. Each of them has its own pros and cons. They have their own way and strengths of building an agents. For example, LangChain and LangGraph, which are very widely used, right? They have they have their this whole thing of uh, I would say state-based agentic solution. So state means, like the one memory is being flown, or the information is being passed from one agent to another in a very sophisticated way. Creo AI perhaps does the role-based agentic solutions in a much better way. Coding and building something in Creo AI is much more easier. LangChain or LangGraph has can be personalized, and you can override the functions very nicely. So it gives you lots of flexibility to write your own things in the agentic AI. And then AutoGen also has its pros and cons. IBM Orchestrator is also there new in the market, and it is also doing a very good job in building different agentic frameworks. So now we'll talk about the agentic system. So as I was saying, right, agentic system has been built on top of the LLM, but rather than just using the LLM, there are other certain components of the agentic system which makes it very powerful. One is, of course, the planning, right? So as I was saying, let's take the example again for the travel planning, right? Now, if you would have just an LLM, you would have to understand how you would prompt sequentially in the correct sequence to the LLM, right? Perhaps first you will understand something for the about that particular destination, and then you will plan accordingly, based on the weather, based on perhaps the budget and everything. But let's say to an agent, if you just say that, hey, I want to do a planning of a travel, and my of a summer holiday, beach holiday, or something like that, with this much of budget, it will do all the planning by itself, right? And it will give you the output, or it will plan accordingly for the number of days, the destination, budget, where you want to go. And then that is basically the planning job, right? Breaking down goals into steps. It does a very good job in planning. Now, once the planning is done, then it may go and ask a specialized agent to do that particular task, right? So, for example, let's say you have planned that you are going to uh, perhaps Goa for some time. Now it will go and book a train ticket or a flight ticket from your place to Goa, right? So that is again one particular action for that. Perhaps it will just go to a ticket booking agent and do the job. So, and then those particular agents, they have perhaps some tools, and then those tools will be invoked automatically. So our agent generally, for one particular agent, it has a plethora of tools, and based on the user input, it will understand which tool to call for. So this is, it will not do any unnecessarily tool calling, and it will only use the tool which will solve the task in the most efficient way. So there is a lot of dynamicity, and there is a lot of planning that goes into the agentic AI solutioning. And memory, it is a very important thing. The agent maintains both short-term and long-term memory. Perhaps, the planning that has been done earlier, that definitely goes into the short-term memory. And perhaps you have already heard things like retrieval augmented generation, right? RAG. So where you are getting different contexts from external sources, and then you are bringing those things into the LLM or in the agentic thing for better generation, right? That is a long-term memory. You are finding some more information from external sources, which is a long-term memory. Or perhaps you are getting some kind of, again, information from a data source, right? From a vector DB dataset or something, and you are using that for your solutioning in a better way. Or let's say a chatbot, right? You are using a chatbot, an agentic chatbot, then the previous past conversation, past incidents, all those things basically are there in the memory. So all this information, right? Just think of how a human agent will react. The agent will have all the things, all his experiences that will help him to solve the task more efficiently. Similarly, in agentic AI world also, one agent, it will not only do planning and then execute the action using another agent's help or by using smart tool calling things. It will also have the memory where all the previous knowledges will be there, and it will try to gather all those information for the efficient solutioning. So also another thing, agent operates in a loop, right? For example, let's say many times, perhaps some of you have experienced that when you are asking a LLM to do certain things, or you are asking the LLM to generate certain things, there will be some problem. Perhaps, one great use case will be the Copilot, GitHub Copilot. Perhaps you have asked it to generate some code, but then you will see that there are certain bugs in the code. Now, so that is the LLM, right? There, you will understand there is a bug. Perhaps you will ask the LLM to define it, or you will do it alone. So this is a one-step process. But then the agent will basically operate in a loop unless and until it is assured that it is giving you a satisfactory answer. So it will reason over what it has generated. It will act, refine, all it will do together so that the final answer that it will provide it to the user is reliable, right? So it is correct. So it will ensure the correctness of the solution, and then only it will provide it to you. And it will also provide context-aware information which improves the reliability, right? So explainability, trust of the generated output is a big thing. It is very important now that the generation that we get from an agentic system or LLM, right? It is quite reliable. It does not hallucinate. We have all known that LLM hallucinates. So in agentic AI, at least, people try to provide more reliability and context awareness, right? And then because of this whole idea of reasoning, acting, and refining loop, uh, and with all the extra information that one can get from the memory and the planning, basically we can be very well ensured that the output that we are getting is correct and secure, right? So it validates, refines, and cross-checks before recommending a solutioning. Okay, so let's talk about planning a little bit, how it basically does it. So planning is what? Basically, let's say you have a complex thing, or let's say you have to read a subject, right? A particular topic, then you will basically understand what are the subtopics and you will read accordingly. So similar things are there in the planning. It is basically to decompose a goal into smaller subtasks. So let's say, for example, if the goal is to resolve server downtime, right? Perhaps there is a server and then some kind of, downtime resolution is needed. Then what it will do? It will go and check the logs. It will diagnose, what is causing so much of, latency in the server, and it will propose remediation. So it will understand that these things are need to be done. These are my sub goals. And for each step, it will try to give us a certain action. It will perhaps use a right tool for getting more data, or perhaps doing some kind of processing on the data. And finally, it will find the root cause, or find out the problem, where the problem of server latency is happening, and it will propose some kind of remediation. So every time, like, planning basically means step breakdown, tool selection, and safe execution of the action that it has recommended. So this is where agentic planning provides safety, structure, and reliability. So before going to the tool calling and the power of tool calling, let's look into one of the very popular examples of the agent, which is the React, right? I think this has been already covered in the prompt engineering thing. It is nothing but where the LLM has been asked to think aloud, basically, what reasoning it is doing, think aloud and state the reasoning, then it choose the action, and then finally the result is given. So this is nothing but a simple React based agent where given a query, it will go, this tool is basically a web search tool. It will go search from the website relevant documents, then it will generate answers given the with the given context that it has retrieved, and it will give us the final response. So now let's say, I ask who is the director of the movie Oppenheimer, then the agent will, the thought or the thinking that it has to do or the planning that it has to do, it will do it, and it will also give that particular information to the user, where it will say that the action it must do is the tool calling, which is basically given here, right? Search tool here, DuckDuckGo search. So it will go and do this particular tool calling action, and the action input it will also give, which is basically Oppenheimer movie director. The observation that is the result that it is getting from the tool calling is basically the observation that you see here. And now with this particular whole information or the whole context that it has retrieved from the web, it will now say that yes, I know the answer, and the final answer it will give, right? So this is one small demonstration of how React works. And React is what I would say, one of the most popular agents, a pre-built agent that is now available and people use to build much larger agentic framework. So most many of the agentic framework systems like LangGraph, LangChain, they prefer a graph-based methodology to build the entire agentic system, which is being shown here. So this is basically a React graph. It gets to an agent. The agent has again a list of tools from which it can call the most appropriate tool dynamically. So here you can see that there is a loop from the agent to the tool. If the tool's answer is not acceptable by the agent, it will definitely review, like as we were looking into, there is this whole feedback loop for the agent. So let's say the tool, whatever answer it has given, it is not satisfactory, the agent will again call another tool or perhaps use the same tool with a different input, and so on, until and unless the agent get a satisfactory answer. So now once the agent understands that the answer that it has got is satisfactory enough, or the context that it is getting from the tool is satisfactory enough to answer the question correctly, it will answer, and then it will go to the end loop. So given this example, it becomes much easier to look into the tool calling part of the agent. This is the second most important component. And agents don't basically live in isolation. They connect to external API services, databases, external knowledge sources, and this allows them to fetch real-time data, like system health, weather updates, or perhaps currency rate. Like these are different, like basic, I would say most popular tools that you can find or connect to an external API, Slack, GitHub, right? So this can give us real-time data. And it can also perform actions, for example, commit to a GitHub, or perhaps sending a message in particular platform, for us, perhaps WhatsApp, Slack, in different ways, right? So one thing is fetching the data, one thing is actions, or it can be also some kind of specialized, it can do other specialized tasks. For example, there are a lot of tools. If you go and search the internet calculator agent, you will see that there is an agent and there are different tools. One tool perhaps for addition, one tool perhaps for multiplication. In that way, right? Specialized operations that each of these tools can do. So tools basically, help the agents to give more functionality, to fetch real-time data, and also to perform actions. Tool calling transforms an agent from a passive advisor to an active operator. This is what makes agents so powerful, right? So they can bridge reasoning with real-world execution. So I see a lot of hands going up. So if I'm not sure if it is an interactive session, but yeah, if someone has questions, I'm happy to answer. Okay, so perhaps if there are no question, I'll go to the next one. So then, as I was saying, right? So the next thing is memory. Memory is something which is extremely important in an agent, and there are basically two memories people generally talk about. One is the short-term memory, or what is currently happening, and another one is the long-term memory, or what is there in the knowledge base and which can be fetched, right? So let's go to the short-term memory. It is basically the context within the current session. It prevents repetition and keeps track of ongoing interaction. So this is very, relevant in a chatbot. Let's say you are asking questions in a chatbot. So whatever past conversation you have had with with that particular chatbot in that particular session, this is all in the short-term memory. So it will not ask you repeated question. It will not ask you again what you have already provided as an answer. So this is very important, right? So we get a real feel that you are talking to a person, and of course, any kind of dumb question it will not ask. But long-term memory is something which is stored somewhere else, right? For example, in terms of in a vector DB data set. So it retains information over time beyond a single interaction, right? So perhaps let's say you have raised a ticket, like whatever ticket it is. Perhaps you are having a problem in the Wi-Fi, and you have raised a ticket. And once it has been solved, after again, let's say 1 week later, the same problem appeared. Now in the long term memory or in the database, it is there that 1 week before also you had a similar problem. So the agent can actually get that particular information of that past ticket and try to see if the two tickets are same, what not same, and basically do the analysis. So that particular information of the ticket that was raised 1 week before, that is basically in the long term memory that has to be fetched, which is beyond a single interaction. It has to learn from that and reuse, right? So this is basically what long term memory is. But then what makes it most interesting is basically the hybrid memory, where agent will basically not only have the short term memory and the long term memory, it will also try to combine both the things. So perhaps from the long term memory, it will fetch some of the most important thing which is relevant to you, the current scenario for which you have been taking the help of the agent, and it will mix both of this information together in a hybrid way and provide you the solutioning in the best way, right? So it will enable context awareness. Context is all those information that is there in the short term and the long term memory. So when context awareness means this, all this past information, relevant information, and currently whatever is going on, those things are taken consider, that builds the context, right? Context for the particular task which you are trying to solve. So, but that particular context is entirely there in the agent so that it can do the solutioning in the best possible way, right? So this will also allow the agent to in the continuity of the reasoning and more tailored response. Yeah. So I think this gives us some of the basics of the agent. It shows us like why agentic system is different from the LLM and how LLM can be used in a more powerful way using the things like tool calling, memory, and planning. And this basically, gives rise to the whole concept of agentic AI. So now I would ask Kaushik to present the next set of topics. Over to you, Kaushik.
Yeah, thanks, Ranjana, for that wonderful intro to agents. Give me a moment. I need to have access.
Mr. Oshik, hello.
Yeah, I think he's pulling up the slides. So in between, if
Okay,
you
okay.
have some questions, for 5 minutes, we
There
can.
is a question in chat box. Can you answer it? How we can vary the output of agent based system since it take decision automatically? Evaluating the decision is very important.
Okay, so definitely one thing is definitely if you want to do it in one shot, then of course to provide more context on information, perhaps like if the decision is based on certain criteria, you can specify the criteria while designing the agent. So I think one of the main thing is basically through prompting only. The agent will definitely have some LLM, so you in the prompting you can mention those criteria. Of course, by that way, the answers will vary and it will take care of the criteria. Another thing is basically another. So this is there is definitely not one single way. Another way is basically to use human in the loop. So let's say some decision has been taken. You can ask the agent to take the input or verify the planning from an user. And only after the user has approved it, it can go ahead for the next set of actions. So that is definitely one other way how you can change the planning, or you can change the planning in a better way. I hope.
Gautam, thank you, madam. Gautam, you are continuously raising hand. Do you have any questions to ask? Gautam V. Okay, madam. Sir, I think Oshik is ready. I can.
Yeah, is the screen visible?
Yes, sir. Can you be loud, sir? Because
Yeah. Yeah. So yeah.
yes.
Yeah. So I think Suranjana gave a good introduction to what agents are. Now let's look at some recent developments in this field. So yeah. So this is so context engineering. I think is a very recent thing that has taken in this domain. So yeah. So Toby, who is like the CEO of Shopify, he tweeted about it, and then Andre Karpathy, who is like a very renowned figure in this domain, he retweeted and then about context engineering, and then things blew up. And then I mean, nowadays you will see a lot of the videos on YouTube talking about context engineering and everything. So what is context engineering? So you have all heard about prompt engineering. I think there was a lecture on it in the last session. So context engineering is basically a more evolved version of it. Prompt engineering is basically when you're instructing an LLM to do something. So say you are make telling an LLM, asking an LLM to maybe write an essay or something. So you give it a lot of instructions to do it in a certain way. It's basically for LLMs. Context engineering. So prompt engineering is what prompt engineering is for LLMs. Context engineering is for agents. So obviously agents include LLMs. So prompt engineering is one part of context engineering, but there are other components as well, which we'll look at too. Yeah, so let's first understand what context is in terms of an agent. So yeah, so this thing Suranjana has already introduced. So you have the system prompt, you have the user prompt, you have long-term and short-term memory, you have information retrieved by the rack system if you have a rack system in your agent, and you have the tools as well. So all of this comprises of the context. So context is everything that the agent sees and has access to. So why is context engineering needed? So yeah, so if you look at a typical agent flow, this is similar to the React framework which Ranjana was showing. So it starts off with so the system and user prompt, which goes into the LLM, and the LLM, based on whatever the task mentioned in the user prompt, decides, okay, I should use this tool to get some more information or to do something. So it calls the tool produces some output. The output then gets appended back to the context. Now the new context is the initial prompt that you have, the thought that was given by the agent, and then the tool output. With this new context, the LLM again decides what to do next. It will generate a new thought, which may involve some another tool calling, and then this will keep on happening till the agent decides, okay, now I know everything to answer the question. So yes, as you can see, the more steps the agent takes, the bigger the context gets. And even though today's LLM have support for huge context windows, longer context often leads to worse performance. Just try to understand why that happens. So yeah, so this is a blog from you about how context fail and how to fix them. It's a very good blog. You can read about it in details. So what it talks about are four big reasons why long
Excuse me, sir.
context.
Can you please come closer to the mic because your audio is low.
No, is the audio better now?
Oh, yes, better now.
Yeah. Okay. So why long context is harmful? So this blog talks about the different reasons why a long context causes problems. The first one is context poisoning. Context poisoning happens when hallucinations creep into your context and then it gets reinforced. So as Rajana mentioned, that LLMs have this tendency to hallucinate. Now, because when the number of steps in an agent workflow increases, there are more LLM calls. So there is a chance of hallucination keeping into your context, which can result in performance degradation. The second is context distraction. So context distraction is basically, say, when your context increases, the LLM might focus too much on the context rather than what it has learned during its training. So you might have heard about things like prompt hacking and prompt injection, where people try to basically make the LLMs do things which it was not trained for. So this is why it happens, because they put details in the context which make the model forget what it was trained to do, and it can do it reveals information which during training it was said that it was trained not to do. So yeah, so that's what context distraction is. So when you have too long a context, the agent forgets what it has learned during its training. The third is context confusion. So context confusion is basically when irrelevant information sneaks into the context. So because there are lots of steps, the agents might do some things which are not relevant to the task. And then this gets appended into your context. So the agent might now start focusing on irrelevant information, which can again lead to the degradation of performance. And the final one is context clash, where there is contradictory information in your context. So yeah, so this is basically, this might happen when, let's say, the agent does multiple tool calls. And maybe one tool call says that, okay, this is something, and the another tool call contradicts what the first tool call said. So now because of this contradictory information, the LLM might get confused and give wrong answers. So yeah, so these are the four main reasons why long context is harmful. So now let's try to see how we can avoid them. So again, there is this blog by Lang Chen, which is context engineering for agents, where they talk about different methods of managing your context, reducing the context length, and they show that how you can apply these methods in LangGraph. So yeah, you can have a look at this blog. So in this blog, they talk about four main methods which helps in managing your context. The first one is writing context. It's basically offloading the context into some external storage, like files or some database or something. This is like the long-term memory, which I think Suranjana talked about. There's another concept called state in LangGraph. So state is like a local variable which each agent has access to during its runtime. So instead of maybe the agent writing things to the long-term memory, it can also write it to the state, which it can then use later on. The second one is, now once you have written context to either the long-term memory or the state, you need to retrieve that when required. So for that, you do the select context, where based on what the agent is doing currently, it will decide that, okay, I need to retrieve this piece of information. This can be through some RAG thing or some rule-based thing. And then it will retrieve that information from either the long-term memory or the state session and add it to its immediate context. So yeah, so that's select context. We will have a code walkthrough where we look at a couple of demos. We will see all of this in action there. The third is compressing context. So in compressing context, basically there are two main methods. One is summarization and the other one is streaming. Summarization is basically used when all the information in context is relevant and useful, but the context is too big to be consumed by the LLM in any meaningful way. So what you do is you need to summarize the context. You can use maybe some kind of a summarization LLM to summarize the context to represent all the information that you have in a concise and compact manner, and then pass that information to the LLM to do further reasoning. Streaming, on the other hand, is basically where you have irrelevant information in the context. Streaming removes this irrelevant information from the context, only keeping the relevant stuff that is required for the task, and thus effectively reducing the context size. The fourth one is isolating context. This is typically used when you have a multi-agent system. So in the multi-agent system, typically each agent has its own context, so that it does not get confused with what the other agents are doing, and therefore its own context length is reduced. Obviously, when you have a multi-agent system, they need to communicate with each other. So they do so by using a shared memory, where they write down the things in the context, and then other agents can retrieve the relevant things that they need from that agent. Again, we will see the example of this when we go through the code walkthrough. So we have examples for write context, select context, and isolate context. Complex context will do not have, but if you want to know more details, you can again look through this blog. It talks about all these four things. Yeah, okay. So now we have understood the basic techniques that are used in agents. Let's now discuss about agentic workflows. As Suranjana discussed before, agents are designed to be autonomous. So they interact with the environment using tools, and then based on what they observe, they decide to do next. Workflows, on the other hand, are predefined paths. They are fixed, so they follow a predefined path, and therefore, because they are predefined, they're predictable, they're easy to understand, and then easy to debug when something goes wrong. However, because they're pre-decided, they might not be able to do certain things. So there is often a debate whether to use deterministic workflows or whether to use a fully autonomous agent. In practice, what we have seen is it's better to combine both things, so have best of both worlds. So some parts of your agentic flow may need determinism, where you will use workflows. Whereas for other parts, you will need the flexibility. And there, the agents play their role where they can do decision making and decide what to do next based on whatever is happening in your environment. So typically, when you build agentic systems, you do it in a hybrid fashion, where certain parts are fixed and certain parts which the agent decides what to do. So yeah, so let's look at some of the common workflow patterns. The first one is prompt chaining. This is the most simplest workflow, where it's basically a linear sequence of LLM calls. Let's take an example. So let's say you are designing an exam paper generator agent. So you may have one LLM call at first, which takes in input, say, the textbook, and then generates question from specific chapters. Then you pass that questions to a second LLM to generate the answers using the chapters and the question that the first LLM generated. This is a straightforward pipeline, which is like the most standard way of creating workflows. The second one is parallelization, where instead of calling the LLMs one after another, you call them in parallel. So let's maybe again go back to that same example of question and answer generation. So now instead of, say, in the second LLM call, instead of passing all the questions together, what you can do is you can have, say, multiple LLM calls in parallel, where for each LLM you give it one question and whatever is the relevant context from the textbook, and it can create the answer for that single question. This again is the example of context isolation that we talked about. So where each LLM is just focusing on one question, so it is not overburdened with everything else. And this leads to better accuracy and better performance of the task output. So yeah, so next we move into the more dynamic workflows. The first one we call as routing. So in routing, there is basically a router. This router can be rule-based, it can be a trained classifier, or it can even be an LLM. The router will decide based on the input task which LLM to call. Again, let's take an example. So let's say you are building a student helper bot, which basically answers questions asked by a student. So now maybe here you have multiple agents, each agent for a specific subject. So maybe for math, you have a separate agent. For physics, you have a separate agent. For history, you have a separate agent. So now when a student asks a question, the router will decide what subject the question belongs to, and then route that question to that specific subject agent. So if the student asks a math related problem, it will route the question to the math agent. The math agent will then answer the question. So that's routing workflow. The next one is orchestrator worker workflow, where you have an orchestrator where, unlike routing, orchestrator is basically, you can think of it like your manager or maybe your supervisor that you have in college. So under a supervisor, there are multiple students. Now the supervisor might assign certain tasks to certain students and ask them to do them. Similarly, in orchestrator workers, the orchestrator, based on the input, may call multiple agents, giving them different tasks to do. And once these agents do their own tasks, there is an aggregator which combines the output of these multiple agents and give the final output. Yeah, again, an example would be, let's say you are analyzing a research paper. So the orchestrator may call one agent to summarize it, may call another agent to generate questions for their paper. And then maybe the final aggregator will combine the output and give a final response. So that's the orchestrator worker model. The main difference between orchestrator worker and routing is, in router, the router decides to call one of the LLMs or one of the agents. In orchestrator worker, the orchestrator may decide to call multiple agents together. And we will see this example very soon. The last one is the evaluator optimizer loop. This is one of the most powerful workflows that typically many agents have. I think there was also another question as well, which was how do you evaluate basically the agent output, because the agents might do incorrect things. So yeah, so this evaluator optimizer loop helps in that. Basically, you have a generator which basically does the task which is given as input, and then you have an evaluator. This typically is another agent which will critique the thing that is done by the generator and provide feedback. Now, based on this feedback, the generator will refine its output until the evaluator is satisfied. A very common use case of this is in code agents. So in code agent, there is one agent which writes the code, and then there is another agent which evaluates whether the code is correct or not, whether it is doing what the task intended it to do. And then based on that, it might give some feedback on the code, which the generator agent incorporates and refines the code. Again, we'll see this in the demo. So yeah, so these are the workflows, typical workflows that people use in building agentic frameworks. Now we can go to the demo. So yeah, so this is a QR code which will take you to a GitHub link where you can look at. So there are notebooks which you can look at. Now we'll just look at the notebooks. You don't need to run it at the moment. You can do it at your own leisure. But let's see that two examples we'll have. So the first one is basically what we talked about, which is the code generator agent. So here basically you have two agents, the code generator and the code evaluator. The code generator will generate the code based on the given task. The code evaluator will evaluate the code and then give some feedback on the code, which will then be incorporated by the code generator agent. And once the code evaluator says that the code is correct, you will get the final code. So yeah, so let's look at how this implemented in LangGraph, which is one of the frameworks which people use to write agents. So yeah, so we will do all the importing of all the things that we require. Now you need to create LLMs. What I am using is WatsonX. So WatsonX is a service provided by IBM, where there are multiple LLMs, open source LLMs, which you can call. It is a paid service. So if you want to have something for free, what you can do is you can use Olama. Olama, I think, was discussed in the last talk, how you can set up Olama, how you can get models. So yeah, so if you want to use Olama, just uncomment these lines. You can comment out this part and you can run them. So, but for this talk, we are going to use WatsonX, and we are going to use the Mistral Small for this example. So yeah, now coming to defining the agent. So in LangGraph, the way you define agents, so there are two components. One is the state and one is the graph. So the state is basically, as we discussed before, it is like a shared storage which every agent has access to. And then the agents can read from that storage and write to it. So if we first define that state, so this is the state for the code agent. It has a task. This is the initial input which goes to the agent, for which the code needs to be generated. Generated code is basically the code which the generator agent will generate. And evaluation is basically contain the feedback which the evaluator agent gives. This both are lists because there's a loop here, right? So maybe in the first pass, it will generate something, and the evaluator will say that it's incorrect, you need to fix this and this. Then in the second pass, it will define the code, and then the evaluator agent will again say something. So all of them are stored in the list. So the first entry of the list will be the first pass, the second entry will be the second pass, and so on. And then you have this iterations wheel. So this is going to track how many times the feedback loop goes on, because you don't want the feedback to loop to be run infinitely. So you want to stop it after certain runs. So that is where we are storing number of iterations. And if this iteration exceeds some threshold, then we stop the feedback loop. So yeah, that's the state. So this state will be shared across both the generator and the evaluator. Yeah. So now, now let's look at the agent part. So this function is basically, we'll talk about this function a bit later, but now let's come to the code generation agent. Now there are two parts. So one is when the iteration is 0. So when the iteration is 0, that means it is doing the code generation for the first time. So it is going to take the task and it will generate the code. You can see here is the system prompt and this is the user prompt. You probably looked at what the user prompt and system prompt means when I think Pooja, I think, was covering prompt engineering. So yeah, so the first iteration, it will just generate the code based on the task. From the next iterations, because now you also have feedback from the evaluation agent, which is stored here. It will try to incorporate that feedback and refine the code. So that is this else part. And this is just calling the LM with the system and the user prompt. It will generate the code. Now, if you have used such ChatGPT and everything, you can see that they generate code and they also generate a lot of text surrounding it. So for when you are building agents, you want only the code. So that's what this function does, which is this extract code from response. So this will extract only the code part out of the entire response, which might contain other stuff which you don't want to have. So yeah, so that's, and then you're storing it in the state. So like I said, the state, the agent has access to the state. So the agent is writing whatever output it got from the LLM and storing it in the state so that the evaluator agent in the next phase can use this. So yeah, so now comes the evaluation agent code. Again, you have the system prompt and the user prompt. And the user prompt takes in the task and the generated code, and it asks us to evaluate the code. And you can see in that system prompt, there is this format in which it tells the LLM to give an output. So this is again an important concept in building agents, which is called structured output, where you prompt the LLM to generate output in a certain structure so that it can be consumed easily. So here we are asking it to generate it in a JSON format with two fields. One is a correctness field, which can either be true or false. So if it's true, that means the code is correct. If it falls, then the code is incorrect. And the feedback, which tells you whether the, so if the code is incorrect, it will give you feedback on why the code is incorrect and what it can do to fix it. Okay, yeah. So then you pass the prompts to the LLM and get the response. And this part just extracts out the JSON from that LLM call. Now this is what we call as a router function. So like we discussed, so if you go back, so here is a loop, right? So in this loop, there's an block conditional conditional flow where if the code evaluator says that the code is correct, then you stop when you give the final code. But if the code evaluator's agent says that the code is incorrect, then you go back to the code generator with the feedback, and the generator incorporates that feedback. So there is this conditional flow here. So for the conditional flow, we need to define this kind of a router function, which basically looks at the evaluation state. And if the correctness field is false and the number of iterations is less than 3, it says that it should regenerate. So that's what this router function does. Now, these are all the functions that you need. Now we will create the graph. A graph is basically the entire agentic flow. So in graph, you have nodes and edges. So we have two nodes. One is the generation node and the second one is the evaluation node, which is for the generation agent and the evaluation agent. And then the edges determine the flow of the agentic framework. So the start is the generation code. So the input will go to the generation agent. And then from generation agent, you have this edge to the evaluation agent. And then from the evaluation agent, you have a conditional edge, as we discussed, which takes in the router function. If the router function returns true, which it will do when correctness is false and the number of iterations is less than 3, then it will go back to the generation agent. And if it's false, then it will just end. That means that the code is correct. So it will end and return you the output. And now you can visualize, well, let's run all this. Yeah, so now you can visualize the graph that you just created. This looks very similar to what we have here. So you have the generator agent and the evaluator agent, and there is a loop based on whether the evaluation agent says that the code is correct or not. If the code is correct, and it will end, and if the code is incorrect, it will go back to the generation. And then this loop will run for some amount of time. After that, it will end. So yeah, so now we can start running the agent. So for that, we need to pass the initial state. The initial state will be the initial task, which is, say, write a function to check if the number is prime. And all the remaining fields are empty. Now we can run this. Yeah, so this is the final output. So you can see the generator agent generated this code, which is prime. And then the evaluation agent generated this evaluation feedback, where it says that the code is correct, and then it generates some feedback. Now, because it said that the code is correct, it does not go back to the generator agent, it just ends. So you have just one iteration, and this is the final output. Here is another complicated example which you can look at. And this is the code that it will generate. This is basically how to restore IP addresses. You can have a look at it. Now what we have built till now is very simple agentic workflow where you have two LLM calls. One is generating the code and the other is evaluating the code. It is more often what we call as an LLM as a judge. So it's just looking at the code, and based on its knowledge, it's telling whether the code is correct or not. But in real world use case, you might have experienced that a code might look correct and you think that the code is correct, but when you run the code, you get runtime errors. So it is very crucial to execute a given piece of code to determine whether the code is correct or not. So for that, we are going to define tools. We are going to define two tools. One is a generate test cases tool, which is going to generate test cases based on the input given. So for example, in the prime is prime in example, it is going to generate test cases to check whether if you pass a prime to the function, it is returning true, and if you pass a non-prime to the function, it is returning false. So that's the generate test case. The second one is a run test case, which will take the generated test cases and the generated code and run them and see which test cases pass and which test cases fail. So let's look at how you can create these tools. So for test case generation, we are going to use an LLM. Again, we are going to use the Mr. Small LLM, and then this is how you define a tool in LangGraph. So it's basically a function, and you add this added tool decorator, and this is the prompt that you give to generate the test cases, and you give the task and ask it to generate 5 diverse test cases for the task. Now we can run this, and let's see for this task what does it generate. So here you can see that it generated 5 test cases. So where is prime 2, so 2 is a prime, so it should be true. 1 is not a prime, so it should be false, and so on. This tool helps you generate test cases for any given task. Next, you have the run test cases. The run test cases basically is used to run the test cases that you have generated using the generate test cases tool. So this is not a non-LLM based tool. So here, basically, you are given the code and you are given a list of test cases, and then it executes each of the test case with the code. And then it says which one passed and which one failed. So yeah, so let's look at it. So yeah, here you can see that I just passed these 2 test cases, and both of them passed. So the code that was generated was correct. Okay, now we have created these tools. Now we need to add the tool to our agent and basically create an agent, React agent. This is what Suranjana talked about. So we're going to create this React agent. LangGraph provides this very convenient function called create React agent function, where you just give it the LLMs and you give the list of the tools that you want the agent to have, and it will create the React agent. So yeah, so this running this just creates the React agent, and this is how it looks like. You have already seen this diagram. So you have the agent and you have the tools. So if the agent decides to call some tool, it will pass over the thing to the tools node. The tools will run the tool and return the tool output to the agent. And then based on the tool output, the agent will decide what to do next. This is a very simple React agent, which we are going to use as the evaluator agent. Yeah, so this function just basically prints this conversion between the agent and the tool nodes in a nice way, which you can see. And now this is basically I'm rewriting now the code evaluation agent to incorporate those tools. So what I'm doing is in the system prompt, I've added that you are provided with the tools to generate test cases and run them. And then I define like what the generate test cases tool do and what the run test cases tool do. And yeah, and then I pass that to the LLM, so the LLM knows that how to use these tools. And then the remaining part is the same. So we ask the evaluation agent to provide the output in this JSON format, and the rest of everything is same. You get the response from the agent, and this is where I'm using this pretty print to print all the interaction between the agent and the tool. So yeah, so this is again the same thing that we saw before of building the graph. And then this is the same task, which is writing a Python function to check if the number is prime or not. So yeah, let's run this. Yeah, so now you can see the run. So, and this is how the message gets printed. So you have the first message, which is a system prompt, which is what we pass, and then the user prompt. Here, user prompt, you are giving the task, and you're also given the code which was generated by the code generator agent. And you're asking to provide the evaluation in JSON format. Now, what the agent does, it first calls the generate test cases tool with this argument. And then the tool is executed, and then it returns all of these test cases. Next, the agent decides that, okay, now I have the test cases, now I have to run the test cases. So I call the run test cases tool. The tool takes 2 arguments, as we have seen. So it takes the code, which was generated by the code generation agent, and then the test cases, which were the test cases generated by the generate test cases tool. Now this tool runs, and the output of the tool is this, which is it says that all of these test cases are passed, so none of them have failed. And because none of them have failed, the agent returns that okay, the code is correct and it passes all the test cases. So now this is what we talked about of context. So this entire thing is a context that is going into the LLM. So as you can see, the context increases gradually with each turn. And it contains all of this. So it contains the system message, the user message, the message, the tools, the tool outputs and everything in the context. So yeah, so this is, again, this was a very simple run, but when the run gets more complex, when you have more loops, the context increases, and therefore you need to manage the context. And yeah, here you can see as the final output, which is the final task that you have. Okay, now this is a more complicated example which I took from lead code. So yeah, so this is the task. Now I'm not going to run this because it will take some time, but you can see the output here. Again, this is the system message and the user message. Now the agent again first calls the generate test case tool, giving it the task, and the generate test case returns a few of the test cases for this task. Now in the next turn, it runs those test cases. So it calls the run test cases tool, giving the code and the tools and the test cases. And now here you can see that in the past, you only have one test case which passed, and all of the rest test cases failed. So based on this tool message, what the evaluation agent decides that the code is incorrect. And then it also gives feedback on why the code is incorrect and what it can do to fix the code. Now, based on this feedback, the generator agent rewrites the code and then passes the code again back to the evaluation agent. The evaluation agent runs again. So now here you can see, yeah, so the first two things are same, the system prompt and the user prompt. And then again, you have the generate test cases, where it generates the test cases, and then you have the run test cases again. And this time, after the code is defined, you can see that all of the test cases passed. There is no failed test cases. Therefore, the evaluator agent says that the code is correct. And therefore, the flow stops and it returns the final output, which is this is the final code. So yeah, so this is a very simple code generation agent example where you have two agents, the code generation agent and the code evaluator agent. And you have two tools to the evaluator agent, which helps it execute the code which is generated. Now there are certain things you can do to improve this. So one thing is we are running. So this tool, the run test cases tool, runs the code directly in your environment. This is not recommended because the LLM can generate harmful code as well. So you don't want to run the code into your environment because it can mess up your system. So what people do, so there are two options. One is you can add a human in the loop, where before executing, you ask the user whether this is the code, do you want to execute the code? And if the user says yes, execute the code, then only you execute the code. The second one, which is a pretty standard practice, is you execute a code in the Docker environment. So if anything goes wrong, your main system is not harmed. There is one thing which you can add to this. There are certain other things which I have mentioned here, which you can look at. So you can use, you can add other tools as well, such as compilers or syntax checkers. You can also use multiple LLMs. So currently, both the evaluator and generator LLM are the same. Both are using Mistral Small, but you can use other LLMs and see. You can have, say, Mistral Small for the generation and say Llama 3 for the evaluation and see how it performs. Yeah, so yeah, these are the things that you can try. So you can, clone the repo and, make changes to this code, basically get your hands dirty and see, and learn how to, create agents. Yeah, so the next one, which we'll talk about, is building a deep research agent. So this is, you might have seen, like if you're using ChatGPT, there is a thing called deep research, where it takes a lot of time to analyze things and then give you a final output. This is something a more basic version of that. What we are going to create here is an agent, something like this. So the main goal of this agent is to generate a report on a research topic. So the research topic is the input. You have the research supervisor agent, which is going to basically generate subtasks for this research topic, and then assign each of the subtopics to one of the research assistants. So this is that orchestrator worker example workflow that we talked about. So the research supervisor divides the research topic into multiple subtopics and then assigns each subtopic to a research assistant. The research assistant has access to a search tool with which it can search the internet and gather information. The goal of the research assistant is to create a draft for the given subtopic. And once it generates the draft, it then passes on the draft to the research evaluator. The research evaluator evaluates that draft created by the research agent, and then it can provide feedback on what to improve and not, and then pass that feedback back to the assistant so that the assistant can incorporate that feedback. So again, you see that evaluator optimizer loop here. So yeah, so and once the assistant does the refinement, it again passes the draft to the evaluator agent. If the evaluator agent says that the thing is fine, then it finally passes on to a summary writer. Summary writer basically takes the output from all of the assistant agents and then combines them into a final research report. So this is what we are going to build in this. So there are certain things you will need. So the first thing that you will need is basically we are using LangFuse. So in the last example, we printed what the LLMs are outputting onto the notebook. But when you are building a big complex agent, you cannot print stuff and try to debug. So what people use is this kind of observability frameworks like LangFuse. There is another called Langsmith. These basically track what the LLMs are producing and helps you debug them better. So we'll look at that example. LangFuse is open source. So what you need to do is you need to create an account in LangFuse and get these keys and add it to the environment. Similarly, for internet search, we are going to use Tavily for internet search. And again, it is free, so you need to create an account and get the API key. Now, yeah, like I said, if you're using watsonx, you will need all this. But you can use Gemini as well. So Gemini is again free, so you can basically log in with your Gmail account and get the Google API key to use Gemini. So yes, those are the things that you will require to run this notebook. So yeah, so now let's look at the things. So these are some of the global variables. One is the number of research areas. So basically, which is basically the number of subtopics that the research supervisor will create. And then max requirement is basically the number of times the refinement loop will run. Again, you can play around with these variables. And then again, we are creating an LLM for each of the agent. And this time we are using Mistral Medium. Again, if you want to use Gemini, you just uncomment all of this and you can use them. We talked about state. So this is the state that the agents are going to use. So it has this topic, which is the initial topic that will go as input. Areas is basically the list of subtopics. So the research supervisor will generate this list. This list of subtopics have this area, which is the subtopic. Draft, which is the draft that the research assistant agent is going to create. Feedback is the feedback provided by the evaluator agent. And then if the evaluator agent is satisfied with the draft, then it will make this the final draft. And then you have this num refinements, which will track how many times the refinement has gone. And then status, the status first starts as not started. Then when the research supervisor, the research assistant agent creates the draft, it will go into draft ready state. Then if the evaluator agent says that the draft needs refinement, it will go into the needs refinement state. And if the evaluator agent says that it's complete, then it will go to the completed state. So yeah, so that's the state basically. Now you define the tool. So this is a search tool, which we are going to define, which is basically the Tavily search. This is one of the more popular search tools which people use. It is going to basically return 5 search results. And then we create the React agent similar to how we created before by passing it to the assistant LLM, this tool. And then we start building the nodes. So this is the research supervisor node. Again, so the goal of this is basically it will return this JSON, which will contain the different subtopics. And yeah, so and then it writes those subtopics into the state areas variable. And then once that is done, then you have the research assistant. The research assistant will look at whichever, so you will have multiple research assistants. Each of the research assistant will look at a single sub area. So that what it fetches here. So it fetches the research area which it needs to work on. And then in the first iteration, it will just produce the draft. And from the next iterations, when the evaluator agent says that it needs refinement, it will basically use that feedback to refine the draft. Okay, now, yeah, so now what you can see here, this again is the example of isolating the context. Now, each of these research assistant has only access to its own sub area. It does not have access to the things which the other research assistants are doing. So this is how you isolate context amongst different agents. Yeah, so now this basically dynamically creates all the different agents. So basically, so you will need 3 research agents, right? Research assistant 1, assistant 2, and assistant 3. So this basically does that. So it dynamically creates 3 research assistant nodes. Similarly, you have the research evaluator agent. Again, this is very similar to the code evaluator, where you're asking it to provide feedback in this JSON format. And then, yeah, and you're extracting the JSON format from this. And you're writing it back to the state. And again, this creates the research evaluators dynamically. And this is again the router function that you need for the evaluation condition. And then finally, you have the report writer, which is again, the goal of report writer is to take all of the drafts given by all of the agents, combine it and generate a final report. So that is what the report writer does. And now you create the state graph in the same way that you created before. So you start with the supervisor, and then you have the assistants and the evaluators, and then finally the report writer. And then there is this dummy weight node, which is basically, it's like a no hop. So if all of the agents does not complete, then the report writer has to wait. So that is what this node does. So it basically waits till all of the assister finishes their draft. And now we add the edges. So yeah, so it starts with the supervisor. Then from supervisor, you have each of the assistant. And then from each of the assistant, you have the corresponding evaluator. And then there is this conditional edge from the evaluator back to the assistant if it needs refinement, else it goes to the report writer. And then again in the report writer, if the final summary is generated, it will end. Otherwise, it will wait till all of the reports are generated. And this is again how the graph looks like. Yeah, so this is again really similar to the initial thing that we have here. And now, yeah, this is how you run the agent. So you give the topic. So they say the topic is Agentic AI, the future of autonomous systems. Yeah, and then you run. Now, I talked about LangFuse, which is going to help us analyze what the agent is doing. So yeah, so that is done by this. So you create a handler like this and then pass that handler to the invoke method. And then you run it. And then finally, the output is stored in this report file. So here you can see how the things work, but we'll look at it in the LangFuse in a moment. But this is the final output which the agent produced. So if I just look at it, this. So yeah, so this is the output which the final research assistant produced. So yeah, so that's the output. Now looking at how the agent worked. So that's where this LangFuse comes into play. So it gives you a pretty nice way to view everything. So let's see what exactly happened. So yeah, So we start off with the line graph. So first is the supervisor agent, which basically takes in, so this was the prompt that you provided, and this was the output which the supervisor agent gave. You can see here, it provided these 3 subtopics for this given topic. Now, after the supervisor is done, it will call all the 3 assistants in parallel. So you can see that assistant 1, 2, and 3 are called. Let's look at assistant 1. So yeah, so there is this agent call, which is the initial agent. So what it does, so this is the input prompt, and what it gives in the output is basically a tool call. So it says that you need to call this tabulary search tool. And then, yeah, so it says that call this tabulary search tool with this query. That happens. So the tool is called, and this is the output that the tool returns. So it returns 5, as we have made 5 outputs. So it gives 5 links and 5 search results. And each search result, you can see it gives the title, the content, and the relevancy score. And all of this then gets passed into the context again. So in the next iteration, if I go, so this is after the tool output is given. You can see this was the initial input, and then this was the agent saying that it needs to call the tabulary search tool, and then this contains the output of the tabulary search. So you can see that output is here. So all the results are here. So everything now becomes the context for the agent. So you can see that the context keeps on growing. And then finally, this is the output by the agent based on whatever information that it retrieved from the internet. It produces this initial draft. So this is what research assistant 1 does. Similarly, 2 and 3 will do the same thing. Then you have the evaluator, which will evaluate the draft. So you pass the draft as the input, and then it gives a feedback like this. That, yeah, so the feedback needed is true, and it gives you feedback. So these are the strengths, weakness, and areas of improvement. This feedback then again goes back to the assistant 1, and based on that feedback, it will again regenerate the draft. And yeah, this keeps on happening till the agent says that it's fine. The code, the draft generator is fine. After that, the final report writer agent is called. And here, yeah, so here you can see the report writer agent takes all of the things. So all the 3 drafts created by the 3 research assistants as input, and generates the final output, which is this. So yeah, so that's how you can use tools such as Langfuse to understand the exact flow that your agent is taking, what each step is doing, what is the input, what is the output. So it gives you a very nice way to visualize and help you debug your agents. So yeah, so you should use tools such as this Langfuse, Langsmith in your agents to make it more interpretable. Yeah, so that's the demo for now. We can now come back to the presentation. So yeah, so we talked about, so just to recap what we have discussed till now. So what we have discussed till now is, we have seen what an agent is, what are the different components. We had looked at different types of agentic workflows. And we have also looked at how you can implement and build different agents in LangGraph. And we have also learned about context engineering, which is fairly recent thing about how to manage the context. Now, to manage the context, you first need to get context into your application. Model context protocol helps you do that. So what is model context protocol? So before model context protocol, basically people were still building tools, documents, etc. But they were all ad hoc. There was no standardization. So in 2000 and basically November 2024, Anthropic, who is the creator of Claude, so you have probably used Claude in maybe doing your assessment and stuff. So they introduced this model context protocol, which is basically a set of standardized rules which govern how an agent will interact with tools, documents, prompts, etc. Basically all the things that can make its context. And then it became popular very soon. OpenAI and other popular frameworks started adopting it. So let's try to understand why this was required. So yeah, so before MCP, there were a few challenges. So since there was no standardized way of interacting with tools, each framework had its own way of creating and integrating tools. This led to many issues. So the first one was adding new tool to an agent. Because the tools and agents were tightly coupled, like you saw in the demo. So now if I had to add a new tool, then I have to make changes in my agent code. So I have to attach the tool to the LLM and then create the agent. So yeah, so I need to make changes to agent code. And then if the agent is deployed somewhere, I have to redeploy the agent. So it was not very easy to add a new tool. The next thing was tool reusability. So let's say I have created one tool, and then you are creating an application which wants to reuse that tool. Now, because there is no standardization, you might be creating your application in a completely different framework or a completely different language even. So you cannot directly use that tool. You have to rewrite the tool code from scratch to use it. Therefore, reusability was an issue before MCP came into the picture. And the third one was using tools with cloud agents. So let's say you are using ChatGPT and you have created some tool which can access some of your file system to do some task. Now you want to give that access to the ChatGPT, but because you don't have access to the ChatGPT code, you cannot integrate your tool to that agent. So yeah, so before MCP is giving this cloud-based agents such as Claude and GPT access to custom tools were not possible. So let's see how MCP solves these issues. Before MCP, this was a scenario. So if your application had to use, say, if your application wanted to access GitHub or do some internet search, so you will have APIs, and then you will build tools around those APIs, which you will then add to your AI agent in the application, which we have seen when we build the agents for the code and the research agent. And now let's say a new agent comes, and it wants to use these tools. Because the new application might be written in a completely different framework or a different language, it needs to rewrite the tools from scratch and then integrate it with the APIs. Therefore, you're not able to reuse the tools that are already present. Yes, this was a challenge. And now with MCP, it looks like this. So all of the tools are behind the MCP servers. Now you can have one MCP server for all the tools, or you can have multiple MCP servers for different tools. In this example, we are considering that for all the type of GitHub tools, we have one MCP server. For all the tools related to internet search, we have one MCP server. And for accessing database, we have another MCP server. Now, if you're creating an application which needs to interact with these tools, what you do is you connect your application to the MCP servers themselves. So the application talks with the MCP server rather than directly interacting with the tools. So if your agent, let's say, wants to use some tool, your application will have an MCP client, which will tell the MCP server, okay, run this tool with this argument. The MCP server will run its tool and then return the output of the tool back to the MCP client, which will then pass it to the agent to do further processing. And now if a new application comes, you don't need to rewrite the server or rewrite the tools. Because the protocol is universal, so even if the application is written in a completely different language, it can still connect with the MCP server and basically exchange messages with the message context protocol. So yeah, so rewriting reusability increases. So you don't need to rewrite the tools that were already present. And also because now your MCP server is a separate entity, which can be in the same, it can be also in a different host. So it's not closely coupled with the application code. So let's say some later point of time, you realize that your application may need another tool for connecting to Slack. So all you need to do is add the MCP server for Slack to your application. You don't need to change the application code. You just need to add some config files. And then it can communicate with the Slack API tools. So yeah, so adding new tools to an agent also becomes very simple. So yeah, there are two common analogies to understand what MCP does. The first one is a microservice architecture, which I think you have probably realized by now. So in microservice architecture, you have a front end, which is basically like the agentic application that you create. The backend is basically the MCP server, which communicates with the AI agent. And then the tools are basically the services which the MCP server has access to. And if the agent application wants to run the tools, it communicates it with the MCP server, and the MCP server runs the tool and returns the output to the agent. Another analogy which the creators of MCP talk about is the USB-C analogy. So before USB-C came into picture, there used to be multiple connectors for different things. So for data, you have a different connector. For audio, you have a different connector. For video, you will have a different connector. With USB-C, everything becomes standardized and universalized. So USB-C became a standard universal connector for all of these things. And with one USB-C hub, you can connect multiple things together to a same the computer. So MCP acts as similar things. So MCP is like a universal adapter for tools, resources, and prompts. So yeah, coming to the MCP architecture. So you have an MCP client, like we talk about, in the agentic application, and then the MCP server may sit on some remote host, and the MCP client and the MCP server communicate with each other. The MCP server exposes tools, resources, and prompts. So we talked about tools a lot, but there are other things which comprise of the context, like resources and prompts. So resources are basically file documents or database records. Let's say, for example, say you are reading some say research paper, and then there are certain parts of the research paper which you are not understanding, and you want the ChatGPT's help to understand what is written. So what you typically do is you go to ChatGPT, you upload the research paper, and then you ask questions. With MCPs, the research papers can sit at the back of the MCP server, and the MCP server can provide the research paper directly to the agent. So you don't have to manually upload it. You can just ask the question to the agent. The agent will request for the paper from the MCP server. The MCP server will find the document, and then the agent can explain whatever is present in the document. That's the example of resource, how resource are served by the MCP server. And finally, you have prompts. So prompts again. So when you're creating MCP server, let's say you create an MCP server for the code agent where you have those tools. Now you know that this prompt works best for the evaluator agent. So you can add those. You can add that prompt into a MCP server, and then whenever the agent is connecting with the MCP server, it can ask for that prompt and use that prompt for its evaluator agent. So yeah, so that's how the MCP. So that's are the things which the MCP server can provide to an MCP client, which then gets provided to the agent. Yeah, so that's the MCP architecture in a nutshell. There is again another demo of how this works. So yeah, so if you look at, so you have this MCP server code, which is basically talks about how you can create your own MCP server. So this is the code server example, where you are again creating those tools. So these are the two tools that we created in the demo. Now we are creating it with this @mcp.tool. This basically wraps it in an MCP server, and then you're also creating the prompt. So this is the prompt for the code evaluator agent, which again the MCP server will expose. And then you can run this MCP server, and to integrate it with the code agent is again simple. So yeah, so basically what you do is you create a client like this. So like I said, your application, agentic application needs to have an MCP client. So you create a client like this by adding this kind of a configuration file, which has the path of the MCP server. And then you get the tools from the client, and this gives you the tools. And you can also get a prompt, and this gives you a prompt from the code evaluation agent. And then when you are running the code evaluation agent, so instead of using the hard-coded prompt, you actually get the prompt from the code server and then add it to your agent basically. And then yeah, so similarly, when you're creating the React agent, you get the tools from the client and add it to your React agent. So this all happens dynamically. So you're not creating your tools inside your agent code. The tools come from the MCP server. And the rest of the things are same. So you run it same and it gives similar output. So that's how yeah, you can create MCP servers and integrate MCP servers with your own agent. So with that, I will stop and hand over to Suranjana for the last part of the talk.
Yeah, thanks, Oishik. So it's already 3:15. So Kishore,
Yes,
how
yes.
much time do we have?
We have to get the Q&A session and discuss this next.
Okay,
If you
so
want 5 more,
okay, so 5 more minutes. Let's
yes,
okay.
you
I'll
can summarize in 5 more minutes.
sure. So in 5 more minutes, I think I just want to touch upon one other important concept. Let me just quickly pull on the slides. Okay, so I also had a demo, but I think for now we will skip the demo. So is my screen visible?
Yes, yes.
So now I think this is something that is also picking up quite fast, which is basically, how do each agents collaborate with each other. So right now, Oishik was just explaining us how agents collaborate with tools using MCP. So this is a protocol by Anthropic, and this is getting, a lot of popularity in building the whole agentic framework. But now in a multi-agent framework, uh, there is a question of how agents are collaborating with each other. Right now, let's say, like let's take an example of, food delivery system, right? So you order food through a third-party app, and then that app is basically sending that request to restaurants. Let's say each of the restaurants or each of the agents, food delivery app is another agent. So the agent has to communicate with each of the restaurant agents, and then there are these delivery partners who are bringing food from the restaurant to you. So which is basically like a parcel that is being passed from the restaurant to you. So now it's not that, let's say you place an order and then you say through the app, and then you say, no, I will go and bring the food by myself. You cannot do that, right? So there is a particular protocol which is been taken care of. It's also not that any delivery person or delivery executive from that particular food delivery platform can go and take your order. So there is a specific protocol that needs to be followed. One delivery person can only, that particular person can only go and bring the food to you, right? So whole protocol is in that system. So similar to that, in the agentic system also, let's say, let's take an example of what Oishik has been showing us, the code generation and the code evaluator. These are two agents, and these agents should talk to each other. So till now, people have used the agentic framework which they have used, for example, LangGraph, where there is a state which is the variable, or perhaps Creo AI. There are again message passing things. That is one way of doing it, but then this is very elementary. Think of a place where each agents are sitting in different servers, and then these servers are quite in a secured private cloud. Now then, this agent message passing is not that easy to do, right? So there are a lot of security protocol that needs to be taken care of. So how to do it in a bigger scale? So there, basically, all these concepts of agent collaboration framework is basically coming into picture. This is basically, very important. This is non-negotiable in a real world agentic scenario, because of security, because also another reason is that so no information gets lost. For example, you want to send text message to between two agents or images. So now let's say two agents can only communicate via text, but then you are sending an image, things will get lost. So a proper protocol is necessary. And this is again a very, very important thing in the whole building the entire agentic system. So there are a lot of things, but since we have very few very few minutes left, so I'll just touch upon the important things. So this is basically Google's agent-to-agent communication protocol, which I will just show. Uh, so here the client requests the tasks and the remote agent executes the task. So one thing is that the agents are not exposed. They are all inside a secure environment. What it shows is only the agent card and the agent skill. So each agent will showcase its agent card, where the skills and the descriptions will be given. What is going on inside, it's only that agent's business. So this is this is a way of wrapping around the agent in a security protocol. And also the message passing part, right? So this is mostly a structured communication using the JSON protocols. And then this is done very smoothly using I would say predefined JSON structure. So as I was saying, like discovery and authentication, it is being all done using uh, things like authentication, OpenID, Connect, and everything. So I'm just going through the slides very fast because of the interest of time. But then this is an important concept, and if you are interested, please go and look into it. And yeah, so another thing I would say, wait, yeah, just trying to, yes. So this is the entire task of A2A protocol. This is basically a JSON RPC 2.0 protocol standardization that is being used for the message passing. So for any, I would say, agentic coding, so basically things like coding concepts like pydantic and then JSON protocols, they play a very important role. And then this is basically the task of A2A communication. One other thing is the life cycle of a task. So let's say you are asking the agent again for some complicated task like the code generation, evaluation, and refinement. The entire thing is one agentic framework, and perhaps this will take some time, right? It will not, you may not get the answer in 1 second, or very fast, or in 5 seconds or something. It may take some 2-3 minutes because lot of refinement needs to go in. Perhaps if you set the refinement number of maximum refinement to be 5, it will take some time. But then the entire multi-agent system will try to keep the entire process alive by sending you streamed message, so that the two agents can have some updates while the sender agent gives the final output in some time, right? So that channel of communication is open. Some message passing is happening in that in that entire duration, so that they know that something is going on and you will get the answer in time. So this is very important. I think why A2A is important is because it sets a universal communication standard. It is secure and it is very robust and collaborative, builds collaborative multi-agent ecosystem. So I think I'll stop here because we do have the MCQ coming up. But if you are interested, then there is this excellent GitHub repo by Google. You can search in the internet A2A samples. You can install it using normal pip things, and then you can play with it. So there is basically a whole ecosystem where a host is basically each agents are uh, deployed in a server, and then there is another agent which can pass messages to that server agent and get some answers from it, get the context from that server agent, builds answer on top of it, and provides you the answer, right? So this is basically small very small demos which is available, as well as very elaborate demos where multi-agent system, how agents talk to each other, right? So one host calling different multiple servers automatically. All these things are there. In the interest of time, I'm not going through that, but feel free to explore that. Okay, with that, I think I will stop the technical sessions. And I think some MCQs are lined. If there are
Thank
any
you.
questions, we are happy to take.
Okay, thank you, Suranjana. Participants, I have pasted a Slido quiz link in the chat box. I request you to register and join. I'll share my screen. Hope my screen is visible. Request the participants to quickly register in the Slido quiz. We'll have a quiz. It is a timed quiz. Each question will have 20 seconds to answer. Basically, first answering who will be answering will be coming in the leaderboard. So totally 10 questions. Each 5 questions will have a leaderboard, and finally we have a quiz winner. Okay. Once it reaches 200, we start. Sir. Request the participants to join quickly. Okay, I'll move to the first question. We'll have the first question of the quiz. It is a timed quiz. We have 20 seconds to answer. Which of the following is the best describes agentic AI? You have 4 options. Okay, B, 88% have chosen B. Okay, B is the right answer. The second question. Okay, 92% of them got the right answer. Third question. Hope you got the idea of the quiz. Why is the tool calling critical in agentic AI? Okay, 84% of them got the right answer. Fourth question. Okay, 92% of them got the right answer. The fifth question. After this question, we'll have a leaderboard. After answering the question, I request participants to come to the Zoom screen. Now we'll be on the web browser. I request the participants to answering after this question come to the Zoom screen. Okay, I'll reveal the leaderboard. Okay, hope participants can see the leaderboard. Ria is on top answering the 5 questions in 30 seconds. Sanjay is on answer the question in 37 seconds. Akash and Mahalakshmi and Aparna Meyer from SVCM. The sixth question. Okay, 95% of them got the right answer. Seventh question. Okay. Eighth question. What is the main challenge in debugging agents compared to workflows? Okay. 74 got the right answer. Which of the following is an example of context poisoning? Okay. The final question. After the question, I request the participants come to the Zoom screen. We'll have the Q&A session after this. Okay, 93% got the right answer. Now I will reveal the final leaderboard. Okay, Priya has answered 46 seconds. 10 questions top stays in the top. Akash stays in the second place. Remaining are the participants who got. Congrats to them all. Now it's for the Q&A session. I will open the chat box. Participants can type the questions in the chat box. Is there any questions? Volunteers, do you have any questions?
I request Veera, Mithun Bala, and Balaji to speak. They have raised their hands.
Okay. I've asked them to unmute.
Now, Zubaida Yasmin.
I have asked Zubin, do you have any question? I've asked you to unmute.
There is some unknown, unnamed person who also
Yes, yes, I'm asking him on to unmute. There's a question. Sir, list of frameworks available other than LangGraph. Koshik, sir.
Vishik, can you respond?
So LangGraph is one framework. So there is QAI, which is another framework, which is much more simpler but provides less flexibility. And there are a couple of new frameworks, one from Google and then one from OpenAI. They have also created their own agent SDKs, which you can look at. They're again much more simpler. They don't provide as much control as LangGraph does. But if you are starting out and you are creating simple agents, they are good to use. And if you want to create complex agents where you need more control, LangGraph is good.
I request one of the participants to speak about both the lectures for 1 minute each. Anybody volunteering? Okay, if there is nobody volunteering, I think Kishore, you can close the meeting.
Okay, sir. Vote of thanks.
Yeah. So, friends, I'm very happy to have requested IBM to come forward and speak today. Two great experts, and I could understand many things, even though I am not an IT person. Okay, I am a core engineering guy, but despite that, I could understand many of the concepts that they were talking about. I am sure that most of you would have enjoyed their lectures and the concept that they presented. I would like to thank both Samantha and Mr. Vaishik for having delivered a great informative lecture today to our participating institutions. And I hope the participants would have benefited from this program. I would like to thank the participants for having come in large numbers and attended this program, and also PAL's PMO, Mr. Kishore, who has been completely doing the session in a great manner. Thanks a lot. Thank you very much. See you on
Thank you.
16th. Next program
Yes,
is on 16th.
yes, sir. Yes, sir. I will announce the next program schedule.
Yeah.
Participants, it is a continuous series of lecture. I'll share the lecture series. So far we have completed the 3 lectures starting from 2nd September. We had the second lecture on 9th September. Today is the 3rd session. The next session will be from Dr. Jaydeep Singh. It is on 16th September. I request all participants to join this session. I have posted the feedback links in the chat box. Participants to fill the feedback form. Next session is on 16th September. Thank you. Thank you, sir. Thank you.
Thanks a lot.
Thank you, sir. Thank you, Ashik and